Okay, so today's notes are going to be on predicting products. Like we talked about the other day, you're going to take the reaction type and the information you're given about reactions, and you're going to use them to figure out what your products are going to be. This will combine the formula writing from concept one that you've been working on, and we will go through one example for each reaction type. We're not going to do combustion. Combustion kind of works a different way, so that one's not going to be included in this. But we will look at these and I'll walk you through how to work on that. Okay. Like I suggested, I would strongly recommend that when I encourage you to pause the video and try an example on your own, you do, and then you hit play once you've done that example and you're ready to proceed. Okay. All right. So we're going to look at the first one. Okay. The first one says the synthesis of magnesium nitride from its elements. Okay. So in this example, you have been told a couple of things. You've been told what type of reaction it is. So you know it's synthesis. And then you have to interpret what the magnesium nitride is. So it says the synthesis of magnesium nitride. What that means is magnesium nitride is going to be our product, okay? So we know that magnesium nitride is going to go on the right side of our arrow. However, we have to write it in formula, like using the chemical formula. So again, you guys, you're going to be practicing writing those formulas, because if I give you words, you have to translate. Okay. So magnesium is Mg. Find it on your periodic table. You should know it's a 2+. Nitride is nitrogen. That's a 3-. Okay. So we're going to crisscross those numbers, and the formula we're going to get is Mg3N2. So that is the product that we are making for the synthesis reaction, okay? Now, why don't you take a minute and think to yourself, and this would be a good time in a sec to pause the video, what are our reactants going to be? What is synthesis? Maybe go back to your notes from the other day and ask yourself and look at like, okay, what was our definition of synthesis? So go ahead, hit pause so that you have time to try to fill this in. And once you have something down and you've tried it on your own, hit play again, and I will show you my response. Okay. Okay. Maybe you realized that synthesis, hopefully you looked it up and remembered that it is when smaller substances, lots of times elements, are combined to form one substance, a bigger substance, which is a compound. Okay. And it says in this example that it is the synthesis of magnesium nitride from its elements. So it's telling you that it's from its elements. Okay. So what elements make up magnesium nitride? Well, magnesium, right? And nitrogen. All right. We're not done yet, though. Okay. What are some things you need to think about? Well, when you're looking at elements, you need to ask yourself, is that element a part of Hunkelbrief? Okay, magnesium is not. So we're going to leave magnesium as it is. Is nitrogen a part of Hunkelbrief? Yes. So that means we're going to put a 2 next to it. Okay, let's try to fill in our states of matter. Let's see how we do. Magnesium is a metal, right? All metals we know are solids. Okay, so we're going to put a little S next to magnesium. You know enough about nitrogen, right? You know nitrogen is a gas. So we're going to put a little G next to that. And then your product is a ionic compound. And without any other information, all ionic compounds in their natural form are solids. So you can just put an S by that. Okay. So now you've figured out the entire equation, and you've correctly filled in your reactants. You've written solid, gas, solid, and you have everything you need right there. Okay, so good. All right, let's go to the next one. the decomposition of aluminum chloride. Why don't you take a second and think about what decomposition is? Write the formula for aluminum chloride. You want to keep practicing those formulas, okay? And then think about what side of the arrow is that formula going to go on. So again, pause it and start there. Okay. Hopefully you figured out that decomposition is when you have one reactant breaking up into multiple products, okay? So aluminum chloride is decomposing into its elements. The formula for aluminum chloride, you would have had to think about the fact that Al is a 3+. I want to point that out to you because a lot of people were getting that wrong on the worksheet that we did when we were practicing formulas. So I just want to remind you that these elements in group 13 have 3 valence electrons. And because they have 3 valence electrons, they are going to lose those 3 valence electrons to be like the noble gases. Okay, keep in mind, even if they're like over here, like indium, and you're thinking like, well, that's really far away from the noble gases. Not in terms of energy levels, it isn't, because keep in mind that like it goes, you know, for example, like 4s and then 3d and then back to 4p. So they all have 3 valence electrons. They are metals for the most part. Metals lose electrons. So group 13 is a 3+. Okay. Chloride, I think you guys have a better handle on, is Cl-. Okay, so then your formula would be AlCl3. That is an ionic compound, so we're going to put a solid on that. Okay. Now, here's your opportunity to predict your products. It says it's going to break down into its elements. So figure out what elements make up AlCl3, and then ask yourself, are any of them diatomic? If so, make sure you write them correctly. So go ahead, pause the video, try the product side. Hit play when you're ready. Okay, so hopefully you have something down. You're going to have alumina because that's the first element, and then you're going to have Cl. Which one of these is part of Hunkelbrief? That's the chlorine. So you're going to put a 2 there. Aluminum is not, so we leave it by itself. Aluminum is a metal, so we're going to put solid. Chlorine is a gas, so we're going to put a G. Okay, that's it. That's all you're doing. All right, now let's look at 3. 3 is a little harder because 3 just says a reaction occurs between sodium sulfide and calcium nitride. Okay, so this one is not telling you what type of reaction it is. You're going to have to figure that out for yourself. So the first thing I would do is write the formulas for the 2 substances we're given in the problem, because that will help us figure it out. So again, go ahead, pause the video, and write the formulas for sodium sulfide and calcium nitride. Okay. All right, so hopefully you've hit play after you've given this a try. Sodium, as you know, is a 1+. Sulfide, remember if it ends in IDE, it's the element. Okay, sulfate is the polyatomic ion you had to memorize. So sodium sulfide, those are your ion symbols. If you put that together, that's going to be Na2S. And then you have calcium nitride. Calcium is a 2+. Nitride is a 3-. Put those together, that's going to be Ca3N2. Okay, both of those are ionic compounds. So, all right. Based on how this is reading, it says a reaction occurs between these 2. That means these 2 are your reactants. So we're going to write Ca3N2 plus Na2S. Okay, it does not matter what order you put those in. If you put them in, like if you had Na2S here and Ca3N2 there, that's totally fine. Okay, so that's good. All right, now, can you tell what type of reaction it is? Okay, based on the fact that we have 2 compounds for our reactants. Okay, when you have two compounds, it's typically going to be a double replacement because they're going to switch ion partners. Okay, what's going to happen is this cation here is going to join with that anion there. Okay, so those two are going to get together. Then I'll use a different color. This cation here is going to go with that anion there. Okay. And you'll notice I'm not highlighting the subscripts because the subscripts don't go with the symbols. You're going to have to figure out the new subscripts. Okay. And this is where maybe taking the time to write the formulas and like write down your ion symbols will make it easier because then you can just look at what you already have. If calcium is going to go with sulfide, I know from over here that calcium's a 2+, sulfide is a 2-. That means we're good. I can just write CAS, okay? If you look here, Na is a plus, nitrogen is a 3-. So if I'm going to combine those together, that's going to be Na3N, okay? So that's your entire equation. I really didn't give you any information that would be helpful for this. So what I will tell you is if you just put all solids for these, because they're all ionic compounds and I didn't tell you that any of them were in aqueous solution, then putting all solids is fine. I should have given you better information for that, but I didn't. Okay, finally, example 4. Nickel reacts with hydrobromic acid. All right, nickel is very simply just an element off the periodic table, okay, and hydrobromic acid. All right, which I'm giving you the formula for because you wouldn't know it. All right, so if it's something that you won't know its formula, I will provide that for you, and then you can do the rest yourself. Okay, so take a second, pause, think about what type this is. And based on what type, maybe try to predict your products. Okay. When you're ready to hit play, go ahead. So hopefully you figured out that this is single replacement because you have an element reacting with a compound. Your first task is to figure out who the element is going to replace. Okay. Now I know this is a little bit tricky and I want to point this out. This is going to seem tricky to you because to you, these are two nonmetals. Okay. Hydrogen's a nonmetal, bromine's a nonmetal. However, what I would say is, which one of these is nickel? Like, nickel is a metal, which means it's going to be a cation. Which one of these for sure do you know makes an anion? Okay. Bromine makes an anion for sure. Remember, hydrogen's kind of a weird element. So if it's not like participating in a reaction exactly the way you expect it to, but you can figure out things from the other elements, trust the other elements. Okay. So nickel is going to combine with bromine. And to be honest, that was my bad because I really should have told you that nickel has a 2+ charge. So I'll help you out here by writing NiBr2 because you wouldn't have been able to figure that out on your own. So I should have given you that information. Okay. And then your element that's going to be by itself is hydrogen. But you need to ask yourself, is hydrogen a part of Hunkelbrief? And yes, it is. Okay. So you're going to put a 2 there. All right. Now, let's go through and try our states of matter. Nickel is a metal, so it's a solid. Okay. I'll tell you right now that all acids are in aqueous solution. They're all mixed with water. If it wasn't mixed with water, it would be like way too dangerous of a chemical. So like all acids are dissolved in water. Okay. Nickel bromide, you could guess is a solid if you want. Realistically, it's probably aqueous now, but we're not quite there yet. So you could label it as either a solid or AQ. And then hydrogen, hydrogen must be a gas. Okay. So you would put a little G by hydrogen for gas. All right. So that is how you predict products. It does take a little bit of practice. You're gonna do a worksheet now that will allow you to practice. Just so you know, on the worksheet, like the first few, you're just going to identify type. Okay. In part B, I'm giving you sentence descriptions of the reactions, but all you're doing is taking those sentences and translating them into equations. Okay. I'm giving you everything you need to know, like, what are the reactants? What are the products? All that information is there in part B. You just need to write the formulas. I'm like writing it out like magnesium nitride. So you're going to practice formulas in that context. And it's also good to be able to like take those sentences and translate them to chemical reactions. Okay. And then in part C, you're actually going to predict the products like we practiced doing here today. Okay. So do as much of that worksheet as you can, upload it to Schoology when you're done, and we'll look at it together when we come back after Thanksgiving. It'll be an ungraded assignment, so you don't have to worry about being right. Just worry about trying so that when we go over it together, we can look at any mistakes you might have made and correct them. Okay? All right. Thank you. Have a good break.